Hello students and welcome to today's chemistry class for S.S.1. In today's class we are going to be talking about the gas laws, but we are going to take part 1 of the laws. But just before we proceed, I would like to tickle your fancy a bit. Do you know why you should not drink water while reading chemistry books? It's because in chemistry, concentration reduces on addition of water. You get the drift? So let's take a quick look at our lesson objectives. At the end of this lesson, the students should be able to state Boyles Law, state Charles' Law, state Gay-Lussac's Law. So let's take the first one, Boyles Law. Boyles Law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature must remain constant. Mathematically, this means the volume is inversely proportional to pressure, and if we are going to remove the proportionality sign, we put an equality sign, and then that means pressure times volume should be equal to a constant. And what this means is that we can equate two different pressures and two different volumes so that we can be able to calculate the difference in volume or pressure. So here now you can see a graphical representation of Boyles Law, that is volume being inversely proportional to pressure. So a quick example now. Example 1. If the initial volume was 500 cm cubed at a pressure of 760 mm mercury, when the volume is compressed to 450 cm cubed, what is the pressure? Now let's take the solution. The first volume is 500 cm cubed, while the pressure is 760 mm mercury. The new volume is 450 cm cubed, while the new pressure is unknown. That's what we are supposed to look for. So using our formula, P1V1 equals to P2V2, we now put in our figures and carry out the evaluation. P2 will become 844 mm mercury. That will be the pressure at 450 cm cubed. Example 2. A 17.50 cm cube sample of gas is at 4.50 mm mercury pressure. What will be the volume if the pressure becomes 1.50 mm mercury with a fixed amount of gas and temperature? Now the solution. The first volume is 17.50 cm cubed, while the first pressure is 4.50 mm mercury. The second volume is unknown, while the first volume is 1.50 mm mercury. Now, using our formula P1V1 equals P2V2, we are going to impute the figures now, and then when we carry out the evaluation, our V2 will be 52.50 cm cubed. Charles' Law. This law states that the volume of a given mass of gas is directly proportional to its temperature in Kelvin, provided that the pressure remains constant. Now, a mathematical representation of this law is the volume being directly proportional to temperature. Now, to get a constant, we are going to remove the proportionality sign and put an equality sign. and this will mean us dividing the volume by the temperature. This means that we can have V1 divided by T1 is equal to V2 divided by T2, so that we can compare two different volumes and temperatures. Here now is a graphical representation of Boyles Law, where volume would be increasing as temperature is increasing. Now, to carry out effective calculation on Boyles Law, you need to know how to convert between Celsius and Kelvin. To do that conversion, 273 plus the Celsius value will give you the Kelvin value. A good example: convert 30 degrees Celsius to Kelvin. The solution is to add 273 to 30. That will give us 303 Kelvin. So let's take an example. A sample of carbon 4 oxide in a pump has a volume of 20.5 cm cubed and a temperature of 40 degrees Celsius. Find the new volume of carbon 4 oxide in the pump if temperature is increased to 65 degrees Celsius. Now let's take a look at the solution. We bring out our values. The first volume V1 is 20.5 cm cubed, while the first temperature is 40 degrees Celsius, which we're going to convert to Kelvin by adding 273 to it. The second volume is unknown, that's what we're supposed to calculate, while the second temperature is 65 degrees Celsius, which of course we're going to convert to Kelvin by adding 273 to it. Now, using our formula V1 over T1 equals V2 over T2 and making V2 subject to the formula, then imputing our figures and taking the evaluation, the second volume V2 will be 22.1 cm cubed. Example 2. A sample of gas occupies 400 cm cubed at 25 degrees Celsius. What volume will it occupy at 200 degrees Celsius at the same pressure? Now take a look at the solution. We'll bring out our values. V1 is equal to 400 degrees Celsius, T1 is 25 degrees plus 273, that will give us 298 Kelvin, while V2 is unknown. T2 is 200 degrees Celsius plus 273, converting to Kelvin, that will give us 473 Kelvin. Now, using V1 over T1 equals V2 over T2, that will give us 400 divided by 298 is equal to V2 divided by 473. Making V2 subject to the formula and taking the evaluation, the final volume V2 will be 634.8 cm cubed. Let's now take a look at Gay-Lussac's law of combining volume. Don't forget, Gay-Lussac has about 2 laws under the gases. Now, Gay-Lussac's law of combining volumes states that when gases combine, they do so in volumes which bear a simple ratio to one another and to the volume of the products formed if gaseous, provided that temperature and pressure must remain constant. So let's take a look at an example. Example 1. For the reactions N2 plus 3H2 to give us 2NH3, that's ammonia. Take a look at their volumes. 1 volume of nitrogen will combine with 3 volumes of hydrogen to give us 2 volumes of ammonia. Now, a second one, 2H2 plus O2 to give us 2H2O. In the same vein, you will see that 2 volumes of hydrogen will combine with 1 volume of oxygen to give us 2 volumes of hydrogen. A third example, Cl2 plus H2 to give us 2HCl. You would see that 1 volume of chlorine combines with 1 volume of hydrogen to give us 2 volumes of hydrochloric acid. All this is buttressing Gay-Lussac's law. Let's now look at a second example. Consider the reaction 2H2 plus O2 to give us 2H2O. A. What volume of steam is formed from 20 cm cubed of hydrogen and 20 cm cubed of oxygen mixed together? B. What gas or gases is in excess and by what amount? So let's look at our solution. The A part. The ratio of their volumes is 2 volumes combining with 1 volume to give us 2 volumes of steam, meaning that 20 volumes will combine with 10 volumes to give us 20 volumes of steam. This means 20 cm cubed of hydrogen will combine with 10 cm cubed of oxygen to form 20 cm cubed of steam. The B part of the question. Oxygen is in excess by 10 cm cubed. Don't forget, in the question you were given 20 cm cubed of it. Only 10 cm cubed was used. So 20 minus 10 will still be left with another 10 cm cubed. So let's look at the summary of this class. In this lesson, we learnt about Boyles Law, Charles' Law, Gay-Lussac's law of. It's now time for a quick assessment to see how much you have learned. Question 1. P1V1 is equal to P2V2 supports which law? A. Charles' law, B. Boyles' law, C. Graham's law, D. Avogadro's law. Question 2. Kelvin temperature can be converted into Celsius temperature by Question 3. A molecule is the smallest particle of A. A matter that can exist in free state, B. An element that can exist in a free state, C. A radical that can exist in a free state, D. A lattice that can exist in a free state. Question 4. The number of atoms in a molecule of an element is called A. Proton number, B. Atomic number, C. Atomicity, D. Basicity. With this, we have come to the end of today's class. Thanks for watching and see you in the next class.